Everyone, good morning. Hope everything is well with you. Hope you guys had a great weekend. A couple of things I want to go over. I did see a question that I do want to address out loud. Basically, the question was, if we don't have exams, do we fail? No, you do not fail. Exams are not based on your class grade will not be based on the exam. That'll just be ignored. But you still have to do the work. You still have to make an effort to do your work. And if you're not doing the work, then obviously your score is going to reflect that. Now, just to tell you a little bit about what we're going to do today. We're going to go over activity 80. After we go over activity 80, we're going to go over the force, mass, and acceleration formula. I did do a review for that. It came after activity 78. It says I'm going over the graph and the formula. So please make sure you look that over, especially if you did the assignment and you did not do well on the assignment. But I am going to review it again today. Also, I don't know how many of you noticed, but I did post a review on graphs on Edsby. I put a PowerPoint up there. So when you look at the PowerPoint, please make sure, it's a great PowerPoint. I thought it explained the concept very, very well. So please make sure you do it, since it goes over the concept of distance and time graphs very, very well. When did what start, JR? I'm a little confused. Hey, Jake. So today we're going to go over 78. I'm sorry, not 78. We're going to go over 80. After we go over 80, we're going to go over the mass and acceleration problem, and we're going to work on those kind of problems so that you fully understand it. It's very important that you understand how to do those problems. Also, if you're unable to log into the stream, please make sure you're watching the stream at a different time. The whole point is for you guys to actually get the class content. But if you're not watching the stream, it doesn't really work very well, does it? So there is one thing I want to address before we get started. And I actually worked with a student to make sure you were able to see this. There are people who are not turning in assignments. And it occurred to me that you may not know how to know whether or not you have an assignment to turn in. If you go into your Edsby page, now my page looks a little bit different than yours, but I can imagine that the process is relatively similar. If you click on your work for my class specifically, you're going to see, I guess the first thing you see is a graph, but there's a tab that says graph assessments, so on and so forth. Okay, if you click on the assessments tab, it lists all of the assessments for this quarter. And next to each assessment, if you submitted it, there's a flag. If you did not submit it, there's nothing. So you'll be able to see which ones. Now, the only exception to that is activity 75. And that's because I would have to go in and physically put in a flag if you had to email it to me because you were having trouble uploading it. But that's a really good tool to be able to give you a snapshot of all of the lessons that are there and whether or not you actually submitted a lesson. So if you submit something and you're like, well, I don't know if it actually went through, then you can go into that screen, take a look, and then see the flag that's there and say, oh, okay, it did go through. Or if it didn't, then you'll be able to know. Or if you want to know, hey, what assignments am I missing? Or have I submitted everything? Am I up to date? Go into that screen. And if you have a flag next to everything, and you have one that has no flag, no submission at all, and it wasn't a manual submission like a photo upload or a document upload, then you'll know you didn't do it yet. Okay, does that make sense? Hopefully that's helpful to you. I would suggest trying that at some point. Edsby is a little bit slow. You're probably not going to see grades go in for the next few hours because Edsby and I have been having an argument all morning. So trying to do things on EDSB has been very slow. So I think I'm going to wait for it to slow down a little bit, and for there to be less people on later today before I go in and grade, because it was a challenge today trying to work EDSB. So, okay. Does anyone have any questions before we get started? And hopefully that bit of information on how to view your total assignments was helpful. Okay. Guys, be nice. Remember the norms. We treat each other with respect in here. Okay. All right. So we are looking at activity 80. Okay. So we're going over the work for activity 80. Number 1, spaceships that travel millions of miles into outer space use very little fuel. How can they go so far on so little fuel? Okay, what did they use the fuel for? Can anyone tell me? What did they use the fuel for? Does anyone know? Acceleration specifically, what else? To exit Earth's atmosphere, exactly. We have gravitational pull that will work against the rocket as it's trying to exit the Earth's atmosphere. So as it's trying to get into space, as it's trying to leave the atmosphere, it needs fuel to create that combustion force in order to move out of the atmosphere. But once it gets out of the atmosphere, okay, Newton's laws, of course, do apply in space. When you're looking at the object in motion, will continue to go in that direction until it's acted upon by an outside force. So it's going to continue to go in that direction, and it doesn't require any additional push to go. So once it hits space, once it comes out of the atmosphere, and there's no gravitational pull pulling it back to Earth, it's going to continue to travel in the direction it was traveling until something interferes with it. Okay, so it does have to use fuel to slow down if it's landing on a planet or if it is changing direction, because now it needs a force to change direction. Okay, but in terms of movement in a singular direction, it does not need much fuel at all. So use Newton laws to explain why it is easier to turn a truck when it is empty than when it is carrying a heavy load. Anybody want to gander an answer to that one? I know you guys are probably typing. So for those who didn't hear the question, let's go ahead and go through the question again. What about mass, JR? Mass is a very important part of it, obviously. But what the question is saying is, why is it easier to turn an empty truck than it is to turn a full truck? Okay, the higher mass, so you need more force to move the truck to when the truck is empty. The heavier the load is, it's harder to push because there's more mass than the empty truck. So less force is needed to get it moving. Okay, that is correct. The heavier the truck, the more mass the truck contains, the more inertia the truck has. The more inertia the truck has, the harder it is to move the truck, the more force you're going to have to put behind the truck. Okay, so again, the harder it is to move the truck with more mass, because it requires more force to actually move it than an empty truck. Okay. Number 3, an engine can exert a force of 1,000 newtons. How fast can this engine accelerate a 1,000-kilogram car? Okay. Now, I'm actually going to use these problems to demonstrate how to use the force, mass, and acceleration formula. Okay, so anyone who is having trouble with the formula, if you guys have the answer, you're welcome to put it up there, and we'll compare. I'm going to turn this slide off because I wanted to get that off the screen. Okay, and let's see how well you can see this. Perfect. So if we look, first of all, the formula is equal to force equals mass times acceleration. And when we go over this formula, I'm going to review it utilizing all the different formulas. But for now, I'm actually going to go with what it is that we're solving for. So here it's saying it can exert a force of 1,000 newtons. So we have force. So force is equal to 1,000 newtons. Okay. And it further says, how fast can this engine accelerate a 1,000 kilogram car? So 1,000 kilograms is mass. Okay, so for this problem, we are given the force and we are given the mass. That means we're solving for acceleration. Okay, so a couple of ways you can do this. You can isolate the variable, and we're going to go over that in a little while, or you can use a triangle, which I'll put up here. Okay, I did this triangle before. Force, mass, acceleration. So if we're solving for acceleration, acceleration is force divided by mass. So acceleration is force divided by mass. So if we plug these numbers in, 1,000 newtons divided by 1,000 kilograms. And that gives us, as some of you have already noted correctly, 1 meter per second squared. Okay, does that make sense? Okay. Does that make sense? Let me go ahead and move out the way so you could see the work. Okay, what do you mean maybe? Or are you talking about Rosie's comment? Okay. So let's go over the second one. Now it says a 2,000 kilogram car. So now we are once again utilizing the same formula, but instead of it being a mass of 1,000 grams, it is a mass of 2,000 grams. And we are still solving for acceleration. Since we're still solving for acceleration, the only thing that's changing is the mass, since we're still dealing with a 1,000 Newton force. Because it is a 2,000 kilogram car with the same force being applied, 1,000 divided by 2,000 is 0.5 meters per second squared. Okay? Does that help with understanding the formula a little bit more? Okay. Now, number 4, use Newton's third law to explain why a blown up but untied balloon flies around the room when you let it go. Oh, JR, I'm actually going to do all 3 formulas once we finish going over the questions for activity 80. So I'm gonna go over all of it again. And if you still have trouble, not only can you watch this video, but activity 78, there's after the post for activity 78, there's a separate video that says I go over the graph and I go over how to do the formula as well. So I also go over how to solve for the formulas, but I am gonna do it in a few minutes. Okay, anyone have an answer to that question? Using Newton's third law, explain why a blown up but untied balloon flies around the room when you let it go. No, activity 81. We're doing activity 80 right now. but I'm not, I removed all of the deadlines out of EDSB. You may have noticed you should be able to turn in your assignments. Well, there's nothing stopping the air from leaving the balloon, but the question isn't, is the air leaving the balloon? The question is, why does it fly around the room when you do that, when it does that? Instead of the air just like, for example, if I were to blow up a balloon and put it on top of a table and let it go, why doesn't the air just leave the balloon? Why does the balloon just go flying? Newton's third law of motion states for every action, there's an equal and opposite reaction. The balloon travels in the opposite direction the air is escaping, so it's propelled forward. That is a phenomenal response theory. That is perfect, by an opposing force. That is correct. Because if the balloon is going this way, the air is shooting out this way, it's propelling it in that direction. That is a beautiful response. Perfect. Okay? Does everyone understand that? Awesome. Well, that tells me you understood it, Meredith, so I'm glad you got that. That's perfect. Well, the air is leaving at the same time, but it's because of every action, there's an equal and opposite reaction. As the air is being pushed out in that direction, it is propelling it. It's the same thing with a rocket. When the fuel is being combusted, it's pushing down. And that act of pushing down is actually propelling the rocket upward. Okay? All right, so motor oil, axle and grease, and other lubricants are slippery. Why do you think people spend money to put these lubricants in their car? Why do we put lubricants in our car, in our engine, in the axles? Okay, why do we do that? So that the gears move easily. That is absolutely correct. If they move easily, what do you have less of? Reduction of friction. Perfect. Okay. So if it has less friction, it runs smoother, and since it's decreasing the friction, what is it also decreasing? If it's decreasing friction, what else is it decreasing? What does friction have a tendency of causing? Actually, a decrease of friction would increase speed if speed was involved. Well, yes, because you're not wasting it with heat perfectly. That's exactly what I was looking for. You're not wasting heat. Okay, so that is absolutely perfect. Awesome. So, any questions on that? Okay, does this make sense? All right, guys, so let me just go over something really briefly, and then I'm going to go over this formula on the board again. First of all, if you do not understand this, please go over it. There were some people who did very, very well on the worksheet. There were some people who did not do well on the worksheet. Not a lot, but I want to make sure if you don't understand it, that you get a good handle of it, okay? So that you can go ahead and retry your worksheet. All right, so we're going to erase this, and all right, let me get a black marker, I think, or I may have actually moved my black marker. Oh, there it is. All right, so the parent formula is force equals mass times acceleration. That is the parent formula, okay? Now, this formula, you can change it to solve for what you're looking to solve for, okay? So let's say we're solving for mass. In order to solve for mass, you need to isolate the variable. Okay, same as in algebra. So force divided by acceleration is equal to mass times acceleration divided by acceleration. This cancels out acceleration, giving you force over acceleration is equal to the mass. So that is how you isolate the formula for solving for mass. Does everyone understand that? Okay, I'm going to show you the next one, and then we're going to, I want to make sure you understand how you isolate the formula, and then we're going to go from there into solving a couple of problems. Okay, so now let's say we take this formula, and instead of solving for mass, we're solving for acceleration. So force equals mass times acceleration. We're dividing by mass on both sides to isolate the acceleration variable. Since you're multiplying here, you need to divide to cancel. Mass divided by mass is 1. So force divided by mass is equal to acceleration. So now here, you solve here for acceleration, you solve here for mass, and you solve here for force. So these are the three formulas that you get out of this parent equation. What don't you understand? What doesn't help? Okay, so apparently you're talking about something other than school. So does everyone understand the three formulas and how I got them? Now there's another way to remember it. Let me go over that with you. This you've seen before because we did it with density. And I'm actually going to, let me do it right here. I have this triangle that I did. And instead of density equals mass over volume, it's force is equal to mass times acceleration. So force is equal to mass times acceleration. Since mass and acceleration are next to each other, they're being multiplied. Here, if I'm solving for mass, I cover mass. Mass is equal to force divided by acceleration. If it's one above the other, you divide. If I want to solve for acceleration, cover acceleration. Force divided by mass is equal to acceleration. Does that make sense? Okay. We good? All right. So I'm going to erase this because I want to go over some problems. Or before I do that, I actually want to go over units because I suspect that part of the problem is some of you don't know what units are. And if you don't know what the units are, then you're not going to plug things into the right place. So the unit for force is newtons. Okay? And that is written as N. The unit for mass is kilograms. And that is written as kg. The unit for acceleration, oh, actually, we'll just put A. And that is meters. Okay, acceleration is equal to meters per second squared. And that's written as, okay? So Those are the 3 units. Okay? Anyone else have a question? Does this make sense? If it's not kilograms, yes, you need to convert it. You must have it in this unit. So if you have something that says 1 meter per second squared, you must convert that to kilograms. So if you take 1 meter is obviously much smaller than a kilogram. So 1 obviously is understood to have a decimal point next to it. So kilograms, it is kilogram, decagram, hectogram. Oh, sorry. Sorry. I don't know why I did that. Hectogram, decagram, and then your base unit of gram, and then you have the smaller ones, which is decigram, centigram, milligram. Okay, so in this case, to go from here to here, I have to move 1, 2, 3 spaces. So 1 meter is equal to 0.1 decameters. 0.1 it is equal to 0.01 hectometers, and it is equal to 0.001 kilometers. So 1 meter per second squared equals 0.001 kilometers. Okay? If you're converting from kilometers to meters per second squared, you'd be going in the opposite direction. So obviously you would be using this unit, but if they gave you kilometers, you'd be doing that. Kilograms, same exact thing. If you were to get 3 grams, 3 grams is equal to 1,2,3.003 kilograms. Okay, so you need to pay attention to what the unit is and make sure you convert. So read your questions carefully. Okay? Anybody else have another question? Any question? Does this make sense? Now, what are you confused about? Give me an idea of where to go with this. Folks, if you make an inappropriate comment that I see and I have to hide it, I'm going to put you in timeout. Understand that. I'm not tolerating inappropriate commentary. Okay? So, now, let me go over conversions. Your scale, and this goes for grams, meters, liters, whatever. Okay, so you have a kilogram. Okay, well, let me not even go into grams. Let me just say kilo, hecto, deca. Okay, and then you have your base unit. And then you have deci, centi, milli. So if we were talking about meters, it would be millimeter, centimeter, decimeter, meter, decameter, hectometer, kilometer. Does that make sense so far? Okay. Does that make sense? You don't convert to force. Forces are in newtons. That's the unit for force. So you don't have to convert force. Usually you'll either have to convert meters or kilograms if they give you a different unit. For example, if they give you a decagram, which you're probably never going to see, or if they give you a gram, you're going to have to convert that to kilograms. Okay, if they give you centimeters or millimeters, you're going to have to convert it to the base unit meters because that's what unit it's in. Does that make more sense? Jay, are you saying no to me or answering someone else? Okay, so these are the units. Okay, what you're saying no to me, what are you confused about? It doesn't make sense. These are just the base units. If you have meters, for example, kilometer is 1,000 meters, hectometer is 100 meters, a decameter is 10 meters, the base unit is 1. This is 1/10 of a meter, 1/100th of a meter, 1/1000th of a meter. Okay? So these are what the units stand for. The base unit is always 1. This is 0.1, 0.01, and 0.001. 1/10 of the base unit, let's say meters, 1/100th, and 1/1000th. Going this way, this is 10, this is 100, and this is 1,000. So in meters, a decameter has 10 meters in it, a hectometer has 100 meters, and a kilometer has 1,000 meters. Okay? Does that make sense? Think of a meter stick. I don't have a meter stick here, but I do have metric tape. If you were to look at metric tape, and it's going to be kind of hard to see here, okay? If you look at metric tape, this is each individual little tiny line. Okay, those are millimeters. 10 millimeters make up 1 centimeter. So a millimeter is 1/110th of a centimeter. 10 centimeters make up a decimeter. A decimeter has 10 centimeters and 100 millimeters. Okay? And then if you were to look at a meter stick has 100 centimeters, 1,000 millimeters. So 1 meter has 10 decimeters on it. So 1 decimeter is 1/110th of the length of a meter stick. It has 100 centimeters on it. So 1 centimeter is 1/100th of a meter stick. And it's got 1,000 millimeters on it. 1 millimeter is 1/1000th of a meter stick. Hopefully that clarifies a little bit. So what's confusing about it? What's confusing? I'm going to continue while you type your question, and then hopefully we can clarify this. So if I have 1 meter, I need to convert it to kilograms. Well, a kilogram is bigger than a meter, right? I mean, a kilometer is bigger than a meter, right? So if a kilometer is bigger than a meter, If I convert a small unit to a larger unit, then my number is going to get smaller. Okay? So I need to, it's going to get smaller by a factor of 1, 2, 3. 10, 100, 1,000. Because in a kilometer, there are 1,000 meters. So 1 meter is equal to 1/1000th. Oh, sorry, too many zeros. I got a little overzealous. 1/1000th of a kilometer. Does that make sense? All right, my chat seems to. I gotta make sure that I'm actually seeing any questions that are coming up. Oh, it's moving. Okay. Are there any questions? I was just going over how to convert 1 meter to a kilometer, showing you using this scale. Does anyone need help with that? Does that make more sense? Does it help at all? Okay. Hopefully you won't have any questions on your assessment that goes over, that forces you to convert. Okay, the main goal is to understand how to use the force formula. What do you mean is it being streamed on a microwave? No, I'm using a computer and I have great internet. I actually have a great signal. So if the lag is not coming from my end, it's coming from yours. Okay. I'm not frozen. So the lag is coming from your end. I have not had any instabilities in my internet. Can I restart what? I can't restart the video. We've been streaming for 37 minutes. You should be able to view it just fine later on. Which lesson do you want me to restart? I can't do the entire lesson over. Which lesson do you want me to do? Oh, no. Oh, sorry. Thank you. My bad. I can't do the entire class. What specifically that says, Elion, what specifically do you want me to go over? I can't start from the beginning and go over all of the questions again. You can view the video after this class is over, but I can't redo the entire lesson. Now, if you want me to go over this again, I can go over that again really quick. Who is this person? If you are not in this class, do me a favor and leave, because we're not here to entertain your behavior. Okay, so I'm presuming you want me to go over this again, so I will. You have a base unit of 1, whether it's a meter, a decimeter. I'm sorry, a base unit of 1, whether it's a meter, a gram, or a liter. Right now, we're pretty much dealing with grams and meters. Okay, so base unit of 1, you either have 1 gram or 1 meter. Okay, If you go along, let's say a meter stick, if you were to look at a meter stick, you have 1 meter is equal to 10 decigrams. Okay? 100 centigrams, or I'm sorry, for some reason I'm converting meters and grams. I have no idea why. 1 meter is equal to 10 decimeters is equal to 100 centimeters and is equal to 1,000 millimeters. What that means. Each individual millimeter is 1/1000th of a meter. Each individual centimeter is 1/100th of a meter. Each individual decimeter is 1/10th of a meter. Going on the other side, each decameter has 10 meters. Each hectometer has 100 meters, and each kilometer has 1,000 meters. Does that make sense? Okay? All right. So when you're converting, and I'll do this again. When you're converting, let's say you're given 276 meters or 270. So let's say they say you're moving at 276 kilometers per second. Okay? There are a lot of meters in a kilometer. Because the base unit in the formula, force equals mass times acceleration, is meters per second, you need to convert this to meters per second instead of kilometers per second squared, by the way. Okay, so if I take 270 kilometers is equal to how many meters? Well, 1 kilometer is equal to 1,000 meters. So this number is going to be bigger than this number. We'll start with that. Okay? So it is bigger by a factor of 1, 2, 3. Because this number is going to be bigger than this number, you move the decimal point 1, 2, 3. So 270 kilometers per second is equal to 270,000 meters per second squared. Okay? So you're literally only moving by a factor of 10. If you're converting meters to kilometers, your number is going to get smaller because there are 1,000 meters in 1 kilometer. If you're converting from kilometers to meters, your number is going to get bigger. Here, if you're converting to, let's say, centimeters, let's look at centimeters. Okay? So I have 30 centimeters. Of course, our decimal point is understood to be here. I am moving 1, 2 places. A centimeter is only a fraction of a meter or less than a meter. So my number is going to get smaller. 1, 2. So 30 centimeters is equal to 0.3 meters. So for whatever reason they gave you centimeters per second, you would be converting it to 0.3 meters per second. Okay? $1,000 meters is equal to 1 kilometer. That is correct. We don't do inches. Inches is an imperial system. Kilometers is an SI system. They're 2 completely different systems. So you will, I mean, you can make the conversion, but you will never ever get in a science lesson to convert inches to kilometers. We don't use the imperial system, inches, feet, yards. We don't use that in science. Okay? Any other questions? Does that conversion make sense? Yes, that is correct. 30 centimeters is equal to 0.3 meters. Okay, so going over how to do the formula really briefly, we went over conversions. Okay, so when we went over the conversions, we know that our three formulas are equals force equals mass times acceleration, force divided by mass equals acceleration, or force divided by acceleration is equal to mass. Okay, those are the three possible formulas that we can use. Okay, so looking at that formula, when you're doing your conversion, when you're doing your calculations, let's say you have a car that has a mass of 3,000 kilograms, and it is moving at a speed of, let's say, 150 meters per second squared. What is the force? So when you set this up, force equals mass times acceleration. Okay, so mass is 3,000 kilograms times 150 meters per second squared, and that'll give you 700, or it'll give you 7,500 newtons, I believe. Just doing the math quickly in my head. 3 times 2. Oh, no, my bad. Sorry, counted wrong. It'll give you 4,500, not 7,500. I was doing 250, not 150. Okay? Now, why is the sky blue doesn't have anything to do with the assessment we're going to be taking? You were so right. I think I need sleep. 45,000, not 4,500. It is between Thursday and Friday. I'll be posting it Wednesday evening, and you'll have 2 days to get it done. You only have an hour once you enter the assessment, but you get 2 days to enter and work on it. Okay? So, it's 15 questions, the same as it's always been. Force is equal to mass times acceleration. Okay. So it'll be between Thursday and Friday, so you won't have class Friday. No, there is no extra credit. You have to do the assignments. And if you listen to the beginning of the session, if you weren't here, the beginning of the session, I went over, I'm glad you understand it better. The beginning of the session, I went over how to identify what assignments you have done and haven't done when you go into EDSB. You can actually go into an area in your assignment list and your assignments are flagged. So if you look at your assessment list in EDSB, you're able to see what assessments were turned in because there's a little purple flag next to it. You'll see what's graded and what's not graded. So off the top of my head, I don't know how many points it is. No, I'm not curving a 79 to an A. If you're in my class and you don't bother with assessments, you get a 0 for not doing it. I mean, you have to do them. That's part of our class. So does anyone have any questions? Basically, at this point, you have to make sure you understand how to do these force, mass, and acceleration. Please do the PowerPoint. Well, the PowerPoint basically is just to help you understand the speed versus time graphs. I have not done the weighting system yet, but the test is a 100-point test, the same as it's always been. Okay. I'm imagining that there are some people in here who aren't actually in our class. So anyway, does anyone have a question? Okay, so you understand everything that's going on? All right, folks. If you don't, I'll leave this chat open for a second if you have a question you want to type for me, but I'm going to end the stream at this point. If you don't have any other questions, I will see you guys tomorrow. We won't have class on Thursday and Friday of this week unless you want a review. I'm happy to do a review, an informal review session on Zoom if you do have a question. Other than that, we will not have class Thursday and Friday. Okay? Have a wonderful day, guys, and I will see you tomorrow.